All right, we're back. We're gonna do number 4. Following those same exact steps, okay? Step number 1, remember, was to get everything on one side. So for step number 1, we're gonna have cosine of 2x minus sine of x is less than or equal to 0. All right, step number 2, write it as a function. Call it f of x equals cosine of 2x minus sine x. Step number 3, where we do most of the work. We have to find the zeros of the function. Okay, the zeros of the function, we're going to set the function equal to 0 and solve it. Okay, now let's look at this. Shadow's in the way a little bit. We have cosine 2x, so something should be maybe going off in your head right now. Fireworks going off in your head. Hey, that we have double angle formulas, right? We have 3 different double angle formulas for cosine. So we could pick one of those that maybe would help us out to simplify this. We have a sine in the problem, so one of the double angle formulas has sine in it, right? We want to go with that one. Isn't it 1 minus 2 sine squared? So this becomes 1 minus 2 sine squared of x minus sine x is equal to 0. And then at this point we want to just maybe put it in descending order. So negative 2 sine squared minus sine plus 1 equals 0. In general, with quadratic equations, it's always easier to solve them if you have your square term is positive. It just makes factoring easier, and on top of that, it makes the quadratic formula work out a little bit easier as well. So I'm going to go ahead and divide both sides of this equation by -1 to get rid of the negative. Okay, so that gives us positive 2 sine squared plus sine minus 1, still equal to 0. Okay, now at this point I'm going to go ahead and make a substitution. So I'm going to let u take the place of sine. So that gives us 2u squared plus u minus 1 equal to 0. So this is something we could solve. It's quadratic, right? We could use the quadratic formula if you want to. Or you could factor it, which I know I always say is my preference, is factoring. So let's do it that way. Have to be 2u times u. And then we would definitely need 1 and 1. We just have to figure out one of these needs to be negative and one of them needs to be positive. This one needs to be positive and this one needs to be negative, so that if we were to multiply this all back out again, we would get this back again. All right, so now we can set each of these factors equal to 0 on their own, which is going to give us 2 answers. Either u is 1/2 or u is -1. And remember, u is just a placeholder. Remember, u is just a placeholder for sine x. So we're going to put sine back into the problem. So sine is either equal to 1/2 or sine is equal to -1. And that's nice equations to solve because those are unit circle values. So where is sine equal to 1/2? That happens at pi over 6 plus 2 pi k. Or it also happens at 5 pi over 6 plus 2 pi k. And then where sine is -1, that's that only happens at one spot on the unit circle. That's at 3 pi over 2, of course, plus 2 pi k, right? All right, wow, that was a lot, right? And we care about solutions for this that are between -2 pi and positive 2 pi. So let's answer that way, right? So within our interval that we're trying to work with, what do our answers look like? So if k is 0, let's start with that. If k were 0 across the board, we'd get 3 answers. We would have pi over 6, we would have 5 pi over 6, and we would have 3 pi over 2. Now, what about if k were -1 in all of these equations? If k is -1, that would mean that we would be subtracting 2 pi from all of our original results. What do you get if you subtract 2 pi off of pi over 6? You're going to get -11 pi over 6. And that's in our interval. Now, if you subtract 2 pi off of 5 pi over 6, you're going to get, what, -7 pi over 6, I think? And if you subtract 2 pi off of 3 pi over 2, you are going to get negative pi over 2. All right, now we also need to consider where the function is undefined. Is this function ever undefined? It's made up of cosine and sine. Are cosine or sine functions that are ever undefined? No. No, right? They don't have asymptotes in their graph. We can plug whatever we want into them and we can always get an answer. So we are done with step 3. Moving on to step 4. I'm going to write it over here. We need to make this number line, right, to create a sign chart. Its ends points are -2 pi and +2 pi. And then we need to put these numbers in order. So we have -11 pi over 6, -7 pi over 6, -pi over 2, pi over 6, pi over 6, then 3 pi over 2, and 2 pi. Okay, now, do we include our zeros? Well, yeah, we do, because there's an equal to bar on our inequality. So we are going to include all these zeros in our answer. We'll have brackets on anything. Then we're going to graph it on the graphing calculator and see what our function looks like so we can fill in what the signs are. All right, here we go. We're going to go to y equals. We're going to graph this. So we're graphing cosine 2x minus sine x. All right. Graph. Oh, you know what? I forgot to adjust the window, but that's all right. I'm going to show you what this looks like first. This was just from 0 to 2 pi, but we want -2 pi to 2 pi. So we really should go back into our window and adjust it. -2 pi to 2 pi. Then graph. And you get something that looks like this. And I don't know if you hear a whining dog right now, but that's going on. So I'm gonna go ahead and let him outside and give you a minute to catch up. I'll be right back. All right, and we're back. So we're looking at this graph. What's going on with it? It goes, it's positive, then it's negative, then it's positive, then it's still positive, then it's negative, then it's positive, then it's still positive. If we check some of our values, if we hit trace, if we type in -11 pi over 6, whoops, that should be the first place we see this graph crossing the x-axis. Yes. -7 pi over 6 should be the second, whoops, I forgot the 7. Should be the second spot where it's crossing. Yes, it is showing it as an x-intercept. the calculator should be saying 0 right there, but it's messing up. See, it says e negative 13, which means times 10 to the negative 13th. So it's just slightly off. And so yes, it seems like we did this correctly. Let's put in the signs. So the graph goes from positive to negative to positive, then it hits 0, and then it bounces back up to positive again. Then it goes negative, then it goes positive again twice. All right? So, what are we looking for? Final step. Oh, you know what? The endpoints. I'm sorry, the ends are positive. Okay, final step. We're looking for where this function is less than or equal to 0. It's like the last example we did together. So we want to look for the negative intervals. We have an interval from negative 11 pi over 6 to negative 7 pi over 6. Right here. We have this negative interval as well. But you know what? We want to also include all the zeros. So there's certain zeros here, like this negative pi over 2, that's kind of off on its own. So I'm going to put that in just a brace. I'm going to go least to greatest. Now we have pi over 6 to 5 pi over 6. And then we also have this other 0 that's kind of floating off on its own, the 3 pi over 2, that we wanted to include. So I'm going to put it in a brace as well. I don't think that this happens in your homework where you have to put these numbers by themselves. I think they have all the problems written so that your answers are always nice, just intervals. All right, so that's it for that one. I'm gonna go ahead and end this video. And remember to try the other 2 problems on your own, and then you can check out the solution sheet that I post that will also be posted under the same module that these videos are under. Alrighty, bye-bye.